Okay, two identical blocks of mass 2 kilogram each stand side by side on a table. So this one here is a 2, this one here is a 2, and they're attached by a 1 meter string like this, and one block is then knocked over the edge. So then what happens in the picture is this block falls down, and then sometime later then the second one gets pulled and follows it thereafter. At what speed does that happen? So first we have to find out how fast this is going right before the string becomes taut. So we want to find out what is the velocity here in this picture. So this is just a UVATS problem. The U is 0, the V is what we want, the A is minus 9.81, the T we don't know, and the S is minus 1. So using V squared equals U squared, which is 0, plus 2AS. So that would be 19.62. So the V here is root 19.62. And then the string becomes taut and both of them move off together. So then we have a new problem, which is a conservation momentum. So we've gone from U1, U2, when the string is slack, and then it gets taut, and now it becomes then V1, and then that becomes V2. So conservation momentum, this one's at rest. So we have M1, U1, plus M2, which is 2, and V2. And you might be wondering why I'm not taking it as a negative, because it's heading down. And it's a bit complicated because it's actually wrapped around on the horizontal table here, where this is positive, so the right means positive. So if we're kind of unfolding this to make it one picture, we have to say both are positive to the right. M1 U1 plus M2 U2 equals M1 V1, which is what we want, plus M2 V2, which is also V1 because they're moving off together. In other words, it's like a single 4 kilogram object with a velocity of V. That's a 0 there. So it will be root 19.62, 2 over 4 is a half. So root 19.62 divided by 2. See what that is. The answer is 2.215. 2.215 meters per second then is the velocity at which it moves off at. So let me just write that down. 2.215